Good afternoon, everyone. My name is Sang-Yun Lee. This study was done with my great collaborators, Yoon-Kyung Lim and Gi-Hyuk Lee. In this study, we introduced MirrorPad, which is a novel interface device contained in a laptop for direct pen interaction. Today, let me show you our work and interesting findings. In the conventional laptop environment, users interact with computers mainly using keyboards and touchpads. However, some activities can be performed more effectively and naturally with a pen. Many popular applications provide functions that enable users to make notes and sketches with a pen. Users can be more productive with these applications if they can use a pen in the laptop environment. The computer market sees various ideas to support pen interaction in the laptop environment. The first option is to use an external pen tablet. The second option is to use an external pen tablet with an LCD display. Both options may not be practical when the portability of a laptop is considered. Though users often use a laptop in an office, they may also need to use it elsewhere, such as in a classroom or while traveling. Carrying a pen tablet or pen display everywhere just for pen interaction is not convenient. The third option is to embed pen hardware in the laptop display. In this case, pen interaction is direct and users do not need to carry an additional device. The computer market sees many pen-enabled laptop products recently. An increasingly popular idea is a convertible laptop. These laptops are convertible between laptop and tablet configurations and can support both keyboard and pen interactions well. The laptop configuration comprises a vertical touchscreen, a horizontal keyboard, and a touchpad. This configuration enables efficient text entry with the physical keyboard and precise pointing and skilled manipulation with the touchpad. In contrast, pen interaction is limited because users should use the pen on the vertical screen. The tablet configuration provides users with a wide horizontal touchscreen. This configuration enables users to perform natural pen interaction like they do on paper. However, text entry is not efficient because the virtual keyboard blocks half of the screen and provides no tactile feedback. As the two configurations complement each other, users can switch between the two configurations depending on the current activity. However, the problem is that some activities need both keyboard and pen interactions interspersed in the same workflow. In such cases, users may need to switch between the two configurations frequently. Configuration switching costs time and physical efforts. In addition, it can make users lose their current context, thereby incurring a high mental load. In short, the idea of a convertible laptop may not work well for activities that require interspersed keyboard and pen interactions. To complement the weakness of the convertible laptop, we proposed the idea of MirrorPad. Located where the usual touchpad is, MirrorPad is both a touchpad and a pen-enabled display that mirrors a region of interest on the main display. Users can use it as a normal touchpad. In addition, they can use a pen on MirrorPad to write on the mirrored region. I will explain the interaction of MirrorPad in more detail. Users can use MirrorPad to control the mouse cursor and perform multi-finger gestures. At the same time, MirrorPad mirrors the content of a region of interest in the main display. For moving and resizing the region of interest, MirrorPad has a cush mode. When the pen is in the hover tracking range of MirrorPad, the cush mode is activated. In the cush mode, the normal touchpad functions are disabled. Users can use touch gestures to move the region of interest. In addition, users can use touch gestures to resize the region of interest. To prototype the MiddlePad concept, we used two Microsoft Surface Pro 3 tablets and an Apple wireless keyboard. The bottom tablet and the Apple keyboard emulate the bottom part of a laptop, while the Omnight tablet emulates the main display. The bottom tablet transmits all events from MiddlePad to the Omnight tablet, and the Omnight tablet transmits the captured image of the region of interest to the bottom tablet. We conducted a user study with the final MiddlePad design to verify how our MiddlePad would support a workflow with interspersed keyboard and pen interactions. Therefore, we decided to compare MiddlePad with the two configurations of compatible laptop. To simulate a workflow with interspersed keyboard and pen interactions, we considered a programming lesson situation in which a user uses keyboard interaction for typing code to solve problems in an IDE, and pen interaction for handwriting answers to questions provided in a PDF file. Then we designed keyboard and pen sessions. In the keyboard session, a user uses keyboard interaction to fill in blanks in a program to make its output equals to a correct answer. In the pen session, a user predicts the output of a given program and writes it on the page with pen interaction. We recruited 12 participants who have used a laptop supporting a digital pen for at least 1 year. The participants were asked to perform 10 sessions under each condition. The figure shows mean completion times of 2 sessions. In the keyboard session, tablet condition was significantly slower than both MiddlePad and laptop conditions. In the pen session, laptop condition was significantly slower than both MiddlePad and tablet conditions. Based on the completion time results, we concluded that MiddlePad was as efficient as laptop condition during keyboard interaction and showed a performance similar to that of tablet condition during pen interaction. In the user study, we observed differences in the annotated results among the 3 conditions. In the laptop condition, all participants could not write horizontally due to gravity. Most of their annotations tended to start at the top and end at the bottom. In the tablet condition, the users interacted naturally with a pen and made many notes. In the MiddlePad condition, the users performed pen interaction similar to the tablet condition. However, we observed that users made notes in a relatively narrower region than that in the tablet condition, possibly because the size of MiddlePad was smaller than that of the main display. Based on the results and observations, we concluded that the final design of MiddlePad turned out to support the workflow with interspersed pen and keyboard interactions effectively. The contribution of this study is not only to present an interface that turns a touchpad into a pen-enabled touchscreen, but also to experimentally validate MiddlePad technique that effectively supports interspersed keyboard and pen interactions on the laptop. This is the end of my talk. Thanks for your attention. There are more interesting contents in the paper, so if you are interested in my presentation, please read the paper.